Hi friends, my name is Narsimha. I am studying my BTech in IRE College. Today, as a part of my AAT Tech Talk videos, in the subject of business economics and financial analysis, I want to share a few topics related to my topic named Demand Forecasting in Smart Grid Paradigm, Features and the Challenges. First of all, what is demand forecasting? Demand forecasting is a field of predictive analytics which tries to understand and predict customers' demand to optimize supply decisions by corporates, supply chain, and business management. In any aspect or in any field, to reach customers' expectations is only the main target. So, by this demand forecasting aspect, means the topic, you can predict the customer's demand and trials to do to reach the expectations. Coming to the topic, introduction. Demand forecasting faces challenges that include a large volume of data, increasing number of factors that affect the demand profile, uncertainties in the generation profile of the distributed and renewable generation resources, and lack of historical data. A hierarchical demand forecasting framework can incorporate the new technologies, customer behaviors and preferences, and environmental factors. So next, with the advent of deregulation in the power industry, demand forecasting has gained considerable attention in energy market operation and planning. Demand forecasting impacts the operational decisions on generation scheduling, reserve and reliability margins, as well as the maintenance scheduling in electricity networks. So this slide and previous slide are saying about the applications with the importance of demand forecasting, by which it faces challenges like large volume, including the large volume of data and increasing the number of factors and distributed techniques and giving them proper analysis of the customer demand. As the number of factors that contribute to demand forecasting increases, the present framework for processing the data requires further revision. So the last lines are indicating that the number of factors are directly proportional to the framework processing, which means that as the number of factors increases in demand forecasting, the present framework means the work which is doing by the person has to be increased. Next, in the smart grid paradigm, demand forecasting plays a crucial role, means a vital role, as it applies to several practices such as demand side management, DSM shortly abbreviated, renewable energy integration, and energy storage planning and scheduling. Smart grid deployments such as energy management systems and advanced metering infrastructure, shortly abbreviated as AMI, provide more efficient real-time control to balance energy supply and demand while offering improved visibility for electricity supply and demand patterns. Next, the key factors, means the first part of our topic, that is features. The second topic is challenges. The key factors means the features of demand forecasting. The elements that ought to be considered in demand forecasting under the smart grid paradigm are as follows. Means the key factors are: first one, weather. Accurate weather forecasts lead to more precise renewable generation such as wind and solar, and demand forecasts in the distribution network. First one is the weather. Second one is the temporal factors, which means electricity consumption is independent on time of day of the week, means weekend or weekdays, the type of day, that is such as a holiday or a special event, as well as the season. The temporal factors, electricity is an example, and electricity consumption will vary from day to day, which depend on the specialty of the day or depend on the such as weekend or weekdays or a special event or a holiday. The energy consumption will varies from day to day. Next, third one is volatility in generation and demand profiles, such as random distributions in consumption and generation are consequences of customer behaviors and the availability of renewable energy resources respectively. Fourth one, electricity price and demand response. In regulated electricity markets, the electricity price is fixed to recover the cost of energy generation. transmission, and distribution. While in a competitive market structure, price is determined based on the balance between the demand and supply. The last line is specially saying us that the price, the cost of an item or a product is determined based on the balance of demand and the supply. For some products in the market, the demand will be increased, but the supply will be decreased. For other product, the demand will be decreased, but the supply of the product in the market will be increased gradually. So based on the demand and supply, the price of the product is determined. Next, fifth one, renewable energy resources. The smart grid promotes the integration of renewable energy resources, primarily wind and solar generation. Wind and solar energy are reliably sources for electricity and deployment at small scale and can diversify our nation's energy portfolio. Sixth one, energy storage. Advanced developments in energy storage technologies enables customers to have large-scale, efficient storage facilities for electricity. Next. So coming to our second topic, challenges. In order to provide more accurate and efficient demand forecast, several challenges need to be adequately addressed, including first one, processing large volumes of data offered by smart meters corresponding to energy usage. Second one, addressing shorter time spans for demand forecasting, that is likely to be 5 to 15 minutes. Identifying various elements that impact the demand forecast in the new paradigm. Well, you see in the first aspect of our topic, there are features. To override the features or to overcome the features, the challenges are very important in this aspect, because to overcome the challenges, then only the features can be available to the person or the user who is using this. In this slide, I have specified the challenges of a smart grid paradigm, that is, first one, processing large volumes of data offered by smart meters corresponding to the energy usage. As we all know, the data is very complex to understand. And second one is addressing shorter time spans for demand forecasting. Third is identifying various elements that impact the demand forecast in the new paradigm, such as climate. So the various aspects or the various elements are climate change, renewable energy integration, pricing schemes, and economic incentives, government policies, and technology developments, etc. And the fourth one is addressing the dynamic behavior of the customers in response to technological development, environmental concerns, and economic incentives. So these are the challenges of the smart grid paradigm. While we overcome these challenges, then only the features, the key factors of the smart grid paradigm are in the performance or in the usage. Next, the needed tools to address the above challenges are required to. To overcome the challenges, the tools required are, first one is the process large volumes of historical data in short time spans. Second one, develop new frameworks for demand forecasting when the customer behavior is transformed as a result of new practices and technologies in the energy industry, and when the historical data may no longer represent the behavior of consumers. Third one, derive the elements that affect demand and contribute to energy management practices in the smart grid paradigm. The increased number of elements considered in demand forecasting can be captured by developing a set of scenarios reflecting the social, economic, and environmental states of the system under which the demand forecasting framework is developed. So, well, coming to a look about my slides. So I'll see the before slides, and this is a diagram. A diagram for showing features and challenges. This is a small pictorial representation. Here we can see the three boxes named microgrid or nanogrid, macrogrid demand profile, and distribution network demand profile, transmission network, price of electricity, distribution network, and price of electricity, which of the first box. So in the first slide, Here we can see the importance of an demand forecasting smart grid paradigm. Next, the key factors means the features that are weather, temporal factors, volatility in generation and demand profiles, electricity price and demand response, renewable energy resources, energy storage. The challenges are processing the data, short spans, and identifying the various elements that affects the demand forecasting, such as climatic change, etc. Addressing the dynamic behavior, and the needed tools are short time spans and derivation, the elements, etc. And then small diagrams. Let's have a look of this. And next. Thank you, friends, for listening to my lecture. I hope my lecture is useful for you for understanding about the topic name. That is demand forecasting by Business Smart Diagram Pattern. Thank you.